AYU mencapai misi yang satu, permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Sejahtera and good evening everyone. Welcome to Pusat Tuisyen Akademi Youtuber with joint venture with EDD Malaysia and Guru Malaysia. So I'm Mr. Peh. Currently I am teaching at KTE College Tingkatan 6 Tumfatiwan Melaka. I'm the on-duty teacher for this week. Again, for your information, Akademi Youtuber Panitia Fizik is preparing for you 2 free online classes. So the Form 5 Non-DLP class will be held on every Friday, 9:30 p.m. And for this week is presented by teacher SlindaNordin with topic of 3.4, tenaga dan kuasa elektrik. And another free online classes is for Form 4 DLP class. Okay, so will be held on every Sunday, 8:15 p.m. Okay, so and other information for you, there will be the link sijil peringkat kebangsaan will be preparing for you. The link after the class will be in, and please fill up with any email you are available within 30 minutes. And today, we are going to continue the second subtopic of Chapter 4, Heats. The subtopic of today will be specific capacity, and you are going to learn about 5 learning standards for this subtopic. So the expected lesson for today is also estimated can be finished within 1 hour. Okay, so in the line here, we have Jai. Thank you, Jai, for always supporting me. And okay, so we have also another 2. So you may actually tell me where are you come from and who are you? Okay, in the line. Okay, so again, thank you for supporting me, Jai. Okay, so without further ado, let us go through the first learning standard of today. Okay, so the first learning standard for today's lesson will be you need to able to explain the heat capacity, and the heat capacity is presented by using capital C. Okay, so here the first define heat capacity. So here the first sentence will be like this. Some objects stay warm longer than others because each object has different ability to retain heat. So that means that if I say here we have 2 objects A and B. So if we give a heat for these 2 objects with same heat, then if the object with higher capacity will be increase the temperature slower. Okay, so this ability we know as the heat capacity of the object. Okay, so hi, here we have Cairo. Thank you, Cairo, for joining my lesson. Okay, so if you have any question, you may just text me in the chat room. Okay, then the third sentence here will be the definition or the definition of the heat capacity. Okay, so if the question asks you what is the meanings of the heat capacity, you must give the almost 70 sentence here. Okay, so the amount of heat needed or must be supplied to an object to increase its temperature by, okay, so here 1 degree Celsius. Okay, so this will be the definition. You must including the amount of heat involved and cause the increase of temperature about 1 degree Celsius. Okay, so the formula related will be like this. So this is actually exactly the same with the definition where the Q represents the amount of heat must be supplied to the object and cause the object increase by 1 degree Celsius. Okay, so here Q represents the quantity of heat supply, and then the delta here represents the change of the temperature. Okay, so here the SI unit, okay, so this is I, the SI unit for heat capacity will be joule per degree Celsius. So you can see the Q is the heat, so with the unit of joule. Then the delta here represent temperature. So it's joule per degree Celsius, or same as joule per degree Celsius can be also write at this format also. Okay. Okay, then the next will be the sentence number 5.1. Okay, so here, an object with large heat capacity will undergo small temperature increase if it absorbs heat. So this is what just now I explained to you. If the heat capacity of the object is higher or bigger, so it actually need more heat to increase the temperature. Okay, so number 6, an object with a small heat capacity will undergo a large temperature increase when it absorbs heat. This will be the vice versa sentence of number 5. Okay, then the next, an object with a greater mass has a higher heat capacity. Okay, so this is a factor affecting the heat capacity. So the mass of the object is greater, that means that it can be condense more heat to cause the increase of temperature. Okay, so the next here, for example, here we have two beaker, A and B. You can just look at this figure, A and B, and they have filled with, okay, so the beaker size is the same, but the amount of water for beaker A and B is different. And they're boiled with the same heat and also duration on one. Okay, so here, after a few minutes, so beaker A with less water will be boiled earlier than beaker B with more water. So from here, you can see the amount or the mass of the water in beaker A is actually less, so that it just need small quantity of heat can cause the increase of temperature or reach boiling point in the case here. Okay, so the next, this is because the heat capacity of beaker B is greater. Or just like I mentioned to you at the sentence number 7. If the mass is greater, the heat capacity is higher. So it needs more time to reach the boiling point. Okay, so this is a concept of the heat capacity. Okay, so Salam, Sejahtera, Jayin. Okay, so kabar baik. Okay, then we continue the next slide. Okay, so we have already finished our learning center 1, where you need to able to explain the meanings of the heat capacity. So for learning center 2, you need to define specific heat capacity of a material. So with the formula of C equal to Q over M theta. So the C here we using small letter c to represent the specific capacity. Just now for the heat capacity, we're using capital C. Okay, so what is the difference between specific capacity and heat capacity? Will be explained in Learning Center 2. Okay, so here, the meanings of specific capacity is the quantity of heat required by a substance of 1 kg mass to increase its temperature by 1 degree Celsius. So you can see comparison between the heat capacity will be involved heat needed to increase the substance by 1 degree Celsius. All this is for just one. But for specific capacity, we fix the mass with 1 kg. So the formula will be this. Okay, so this is the difference between the specific capacity and heat capacity. Okay, so you can see here, the formula will be Q equal to M delta theta. So delta theta here is the change of temperature. Okay, you can see here the Q is the quantity of heat supply with the unit of joule. Then the change of temperature with unit of degree Celsius, and the mass will be kg. So all this will cause the unit of the specific capacity become joule per kg per degree Celsius. Oh. Okay, so here, as I mentioned just now, the C, small c represent the specific capacity is actually comparison between two objects with the same mass. Okay, so we emphasize the same mass. And this will be different with the heat capacity, where will be influenced by the mass of the object. The bigger the mass, the higher or the greater the heat capacity will be for the heat capacity. For the specific capacity, it will be specific comparison between two objects with mass of equivalent to 1 kg. Oh, this is a different. Please take note for this. Okay, then number 2. Okay, so here you can look at the picture. We have 3 different material here with different C. Small c represent as a specific capacity. So the copper block have the smallest value. Following aluminium is 900 is slightly higher, and here will be the last one. Water have a greater value of C. Okay, so what is the meanings of the lower specific heat capacity with small c value? Okay, so here warm up and cool down quickly because it takes much less energy to change the temperature. So that means that the copper with smaller c, if we have same amount of Q provided to 3 of the material listed here, so the copper will be showing the highest increase of temperature, okay, because the capacity of heat for the copper is actually smaller, okay, compared to aluminium and water here. Okay, so that means that it is a good heat conductor. And example here will be mostly of metal. Okay, so on the other hand, the water is actually one of the example of the highest specific heat capacity material. Okay, so it will be given less increase of temperature when the heat is provided. Okay, you can see warm up and cool down slowly because it takes much more energy to change its temperature. Okay, so it will be a poor heat conductor or good heat insulator. Okay, so the example here we have the wood, grass, and rubber. Okay, then the next here we are to discuss the heat transfer and thermal equilibrium between two objects. Okay, so the basic concept regarding the thermal equilibrium we discussed already at subtopic 4.1. Okay, so here we continue applying this concept in the specific capacity. Okay, so when two objects with different temperature come into contact, so you can just look at the picture, A and B object is contact with each other. The heat flow will be flowing from hotter object to colder one. So that means that will be flow from the object A to B. All this is what we go through at the last week. Okay, so this process continue until both objects reach same temperature, and this condition we know as thermal equilibrium. Okay, so during this process, the amount of heat absorbed by the colder object is equal to the amount of heat released by the hotter object. Okay, so this is what actually we want to discuss today. Okay, so you can see object A will be providing heat to B. Okay, so that means that heat released by object A will be going to absorbed by object B. And this is what we're going to calculate today, okay, because it involves the change of temperature. Okay, so C, if no heat is lost to surrounding, the total energy involved remain constant before and after the heat transfer take place. Okay, so this is the assumption we going to apply for most of the calculation. Okay, because if let's say we involving the heat loss, the calculation will become complicated. Okay. Okay, so here, this principle is known as the conservation of energy. So that means that energy released by object A will be going to absorb by object B. This is the concept where we applying the conservation of energy. Okay, so which step the energy will be cannot be created or destroyed, can only transfer. Okay, so the quantity of heat Q absorbed or released by substance can be calculated by using this formula. Q equal to MC theta. So the theta here referring to the change of temperature, M will be the mass of the object, and then the C will be the specific capacity. Okay, so if we look at the figure, so A object will be involve the Q release to B. Then it will be equal to Q absorbed by object B from A. Okay, so this is a statement where we discuss at E here. Okay. Okay, so in the line here we have Jimmy. Hello, Jimmy. Okay, so thank you for support me here. Okay, so let us go through the checkpoint. Okay, so that means that the learning center 2 we have finished already. Okay, so now test yourself. Jimmy and others, please do together with me for the checkpoint question number 1. Okay, so the question will be like this. The specific capacity of the aluminum is 900 joule per kg per degree Celsius. Okay, so which statement explain the specific capacity of the aluminum correctly? Okay, so again, you have to look at the definition. Okay, so hi, we have Kai Xuan, and together with Kawei and Hui Xuan, hi everyone. So you may actually show your answer for question number 1 in the chat room, then we can check together the answer here. Okay, so here again, we need to understand the definition of specific capacity. It will be, as mentioned just now, the quantity of heat required by substance of 1 kg to increase the temperature by 1 degree Celsius. Okay, so here we look at the first option. 1 kg aluminum absorb 900 joule of the energy during heating. Okay, so you can see the statement A here do not involve any parameter related to temperature. So they will be wrong. Please consider wrong. Okay, hello, Yuan. Okay, so here, so the option A is definitely wrong already because it's not meets the definition of specific capacity. It must involve heat, mass, temperature. Okay, so the B, the temperature of 1 kg of aluminum will rise by 1 degree Celsius when it absorbs 900 joule of the heat energy. Okay, so seem like this option B is possible, right? All possible. Okay, so we have NH Han also in the line. Okay, so answer from Jimmy is B. Yes, I also have same idea with Jimmy currently. Okay, but we still have to go through C and D. We want to choose the best answer here. Okay, so the temperature of 1 kg of aluminum will drop 1 degree Celsius when absorb 900 joule. Okay, so here will be wrong because when we absorb heat, temperature expected increase. So here option C is wrong already. Okay, so the last aluminum require 900 joule of heat energy to increase its temperature by 1. Okay, again, this is wrong because it's not involved of mass. So answer is B, I think. Yes. Jimmy, you are correct. So others is also encouraged to do together in the chat room. Okay, so we go for question number 2. Okay, so the question number 2 will be like this. 2 metal blocks of the same mass P and Q are heated simultaneously with identical heater. Okay, so that means that they're providing the same amount of heat for P and Q. And where they have the same mass here also. So after 15 minutes, the temperature of the metal block Q is higher. So temperature of Q is higher than temperature of P. Okay, so that means that temperature of Q is higher. So it should be have the smaller C, right? Because just how we mentioned, smaller specific capacity will given higher temperature changes, right? So this is a concept we go through just now. Okay, so in the line here we have Darwin. Hey, hello Darwin. So the tips here will be, if the specific capacity of substance is smaller, so the heat required to rise the temperature will be less. So that means the Q required less. Okay, so here the Q expected will be smaller because it given the greater increase of temperature. This is the concept we explained just now. Okay, we look at the option A. Specific capacity P is greater. No. So if follow the hot tips, the specific capacity of P should be smaller. So here, wrong already, the first option. Okay, and then the next option here, specific capacity of P less than Q. So I think the second option is correct, right? Okay, then C is specific latent heat. Okay, so specific latent heat, we haven't learned. This will be at 4.3, where involving the changes of phase. Okay, we providing the heat causes a substance to change the phase without change the temperature. This is going to learn at 4.3 or A1. So answer here, we are very clear that this should be B or A1. Hey, the first one, specific heat capacity P. Okay, so here in this question, the specific capacity Q is smaller. Okay, so the Q is smaller, sorry, is actually A. Just now, I think I mistake already. Okay, so here, because just now we mentioned already, the temperature for object Q will be higher than P, right? So the C of Q will be smaller than P. Okay, so answer is A. You want? So answer should be A. Okay, then now we go for our learning standard 3. Okay, so the learning standard 3 involving the conducting experiment where we want to determine the specific capacity of water and specific heat capacity of aluminum. Okay, so here you can just go through the step and the theory and the textbook. Okay, so here again, the experiment aim is to determine the specific capacity of water. This is the first experiment. Okay, so the material involved will be polystyrene cup, water emission heater. Okay, so here we're using 50 watts for the power. Tissue paper. Okay, so the tissue paper is actually used to cover the polystyrene cup so that the heat loss to surrounding can be decreased. Okay, and then we have the power supply, thermometer, stirrer, electronic balance, because we want to measure the mass of the water. Okay, and then we have the stopwatch to have the duration for the experiment. Okay, so the procedure, first, apparatus is set out as shown in figure. Will be like this. Then the cup is filled with the m gram of water. Okay, so here, we're using 200 grams. So actually is equivalent to 200 ml. Right, because the density of water is 1 gram per cm cube. So 1 cm cube equivalent to 1 ml. So that means here we'll be using 200 ml water. Okay, so the initial temperature we recorded as theta 1. Then the heater is switched on, and at the same time the stopwatch is started. The water is stirred continuously so that the temperature is uniform. After 10 minutes, the heater is switched off, the water is stirred, and highest temperature of theta 2 is recorded in table. So that means that we're going to measure initial temperature and temperature after 10 minutes. Okay, so this is a data for your reference. Okay, so here, the heater just now in the apparatus already labeled as 50. So this will be 50 watt. Then the time taken is 10 minutes. You have to change to second because for the calculation, we will using SI unit for temperature, for the time. But the temperature actually we can remain as degree Celsius because the unit, just how we explained, we have the joule per kg per degree Celsius. Okay, so the mass will be in kg. We follow the unit we use. Okay. Okay, so here, the formula going to use will be Q equal to MC theta and Q equal to PT. Okay, so the Q equal to PT actually is not new formula for you all. So P is power. We have a definition of rate change of heat where you learn already at Form 3 actually. Okay, so that means that after we arrange, Q will be power times T. So the power times T here, that means that the power supply given the heat to the water. This is the heat released to water by power supply. Okay, and then it will be absorbed by, so this will be heat absorbed by the water. This will be equal because we assume that there will be no any heat loss to surrounding. Okay, so PT equal to MC theta. So the change of theta here will be temperature after 10 minutes for theta 2 minus initial temperature. Okay, so we substitute all the value. So you may get the value for my reference data here will be 4,255.32. Okay. Okay, so this value is actually slightly higher than the actual value of specific capacity of water, which is 4200. Okay, so why? So let's discuss here. Okay, so here, polystyrene cup is used instead of the glass beaker. Okay, so why we using polystyrene cup? Okay, because polystyrene cup is a poor heat conductor. Okay, so it may reduce the heat to surrounding. And according to the procedure, you actually can cover the polystyrene cup with tissue paper lah. Okay, so additionally, the polystyrene cup has a low heat capacity. So meaning that the amount of heat absorbed is negligible, so can be ignored. Okay, so as mentioned just now, the specific capacity obtained in experiment is actually higher. All this is what we get is slightly higher than standard value, where I mentioned to you just now, equivalent to 4,200. I can answer yes. You can just answer, or you have any doubt, you can ask in the question. Sure. Honey, right? Honey. Okay, honey. So welcome to my lesson. Okay, so the next. So the discrepancy is due to heat loss to the surrounding during the heating process. So that means why we have the different value for our experiment, which is slightly higher than expected. So this is because the heat loss is already occurred. Okay, so even though our calculation here is actually assuming that there will be no any heat loss. Okay, so that means that if without heat loss, the final temperature expected actually is higher. However, what we measure is actually lower. It's due to actually the heat loss to surrounding. Okay. Okay, so the conclusion for this experiment, there will be the specific heat capacity of water determined from this experiment is 4,255.32 joule per kg per degree Celsius. Okay. Okay, so now we go for our second experiment, where it will be to determine the specific capacity of the aluminium. Okay, so the procedure, okay, so the apparatus involved will be aluminium block, will be this, tissue paper, oil. Okay, so here this is the oil. Then emission heater, again here, the heat will be provided to the aluminium block by emission heater. Then we have the electronic balance to get the mass of the aluminium block. Then we have the wooden block, and we have the stopwatch. Okay, so the arrangement will be like this figure. Okay, so again, we go through a procedure. Okay, so the apparatus is set out as shown in figure. Then the mass of aluminium cylinder or aluminium block. Okay, so it's determined using the beam balance. So we will measure the mass of the aluminium block. Okay, and then the thermometer is inserted into the hole of the aluminium block. You can see here. Okay, because we want to measure the temperature of the thermometer. Okay, so here, oil is added into the hole to ensure the good thermal contact between the thermometer and the aluminium block. You can see here. The hole here, besides we place the thermometer, you have to put the oil also. Okay, so the oil is ensure that the conductivity between the aluminium block and the thermometer is in good contact. Okay, so we can increase the accuracy of our measurement. Okay, so the initial temperature of the aluminium block theta1 will be recorded, and then heater is switched on. At the same time, the stopwatch will be started. So time taken for this experiment will be 10 minutes. And after 10 minutes, the heater is switched off. So the heater will be this now. So you have to turn off your power supply. So the highest temperature of the aluminium block, theta 2, here is theta 2, is recorded in the table. Okay, so again, here we have the reference data. Okay, so in the line here we have Mignon. Hello, Mignon. Thank you for joining my lesson. Okay, so the reference answer here, again, the power for the emission heater, because we're using 50 watt. So this will be follow the power rating in our emission heater. So the time taken, 10 minutes, change to second, become 900 seconds. The mass of the aluminium block will be 1 kg, where we measure by using the beam balance on. Then the temperature initial recorded 25 degrees Celsius. Then the final temperature here will be 56 degrees Celsius. Okay, so the decimal place 1, we follow the sensitivity of the thermometer we use. Okay, again, we're using the same formula where I explained already just now. So the PT here is actually the heat, is a heat supply or release to aluminium block. Then MC data here is a heat absorbed by aluminium block. Okay, so and for calculation, we will assume there will be no any heat loss. Okay, so the formula will be same as just now one. So we just substitute our all value. 50 come from here. 600 come from time second. And will be the mass of the, okay, so here is the mass of the aluminium block I want. So here we have typo error. Aluminium block. Then the temperature, theta 2 is the final temperature, 56. Then the initial temperature will be 25. So where we get the value, here is about 967.74 joule per kg per degree Celsius. And again, the value we get in the experiment is actually slightly higher than what we should get. Okay, so reason will be discussed here. Okay, the first, okay, so you can look at the figure. So the tissue paper and the wooden block were used to reduce the heat loss from the aluminium cylinder to surrounding. Okay, so this can be used as a precaution answer if the paper 3 question asks you related to this experiment. Okay, then second, this is also another precaution answer for this experiment. So a small amount of oil was placed into the hole to ensure good thermal contact between the bulb. The bulb, that means the, okay, so here, the bulb will be here lah, thermometer, the end of the thermometer here. So we know as bulb. Okay, so the bulb have a good contact with the aluminium. Okay, so this allowed thermal equilibrium between the thermometer and block aluminium to be reached quickly. So as a result, thermometer reading accurately reflect the temperature of the aluminium block. Okay, so we want to make sure the thermal contact between the thermometer and the aluminium block is good, so that accuracy can be increases now. Okay, then here we want to discuss why the value of our specific capacity of aluminium obtained through experiment is higher than the actual. Again, this is due to the heat loss to surrounding. Okay, so this is because some heat was lost to surrounding during the heating process. So in our calculation, we actually assume there will be no any heat going to release. Okay, so that means that the temperature final suppose we get is higher, but in this experiment we get 56. Okay, suppose we get higher than this. However, this is lower because the heat is lost to surrounding during the experiment. Okay, so conclusion, here the specific capacity for the aluminium determined from the experiment is equivalent to this value, what we get, 967.74 joule per kg per degree Celsius. Okay, so we have already finished the learning standard 3. Okay, so now let us continue to test yourself whether you understand the discussion just now in learning standard 3. Okay, so this is the objective question. So let me read the question first, and you may show your answer in the chat room, students. Okay, so diagram 17 shows a lead block. Okay, so we have the lead block, iron block, and aluminium block. All the block have the same mass. Okay, have the same mass, and heated with same amount of heat with in 50 minutes. So the specific capacity, each metal is different, you can see. Okay, so in the line here, we have Justin. Hello, Justin. Okay, so here, the theory again, we need to understand the value of C here. Okay, so again, so the C smaller. Okay, so here the smaller C is actually the lead block. So the smaller C will cause the increase of temperature is more with the same amount of mass together with same amount of the heat. Actually, this is Q. Okay, so that means that we expected with the small amount of heat, same amount of heat and mass with smaller value C smaller, the temperature changes will be higher. Okay, so that means that the aluminium will give us the higher increase of temperature among these three material block. It will be like this. Lead has a lower C than iron. Therefore, final temperature of lead is higher than that of the iron block. Okay, so on the other hand, the aluminium block with higher C will give us the smaller changes of temperature. Okay, so in the line here we have Ziyuan. Hello, Ziyuan, and Jimmy already gave us the answer. D. So we see whether answer from Jimmy is correct or not. So other is also encouraged to show answer in the chat room. Okay, so which statement is correct at the end of the 50 minutes? Okay, so the first, the lead block has the lowest temperature. So wrong, as mentioned, because the C value for lead block is lowest, it will given the highest final temperature. So the A option is wrong. Aluminium block have the highest final temperature is strong because aluminium block have a greater C. The changes of temperature will be the lowest. Okay, so here wrong also, lowest. Okay, then the C final temperature of iron block is equal to aluminium is wrong also because they have different C. So the temperature of iron expected higher than the aluminium because the C for iron is smaller. Okay, so that means that the D should be correct. Okay, so the final temperature of lead block is higher. Yes, correct answer is D. So answer from Jimmy is correct. Okay, so good. Okay, so now we go for question number 4. Okay, so diagram 14 shows an apparatus setup to determine the specific capacity C of the aluminium block. Okay, so this is the experiment just how we explained together. Okay, so which step cannot increase the accuracy? So this is the precaution step just now actually I emphasized on. Okay, so we look at one by one. So you may also show your answer in the chat room by one. Okay, so wipe the aluminium block with cotton. Is it able to increase the accuracy? It should be right because it can reduce the heat loss to surrounding. Okay, so A is can. Put the aluminium block on the polystyrene sheet. Again, the polystyrene is the material with higher specific heat capacity. Okay, is a insulator, so it will be also reduce the heat to surrounding. So this also can. Okay, then C, cover the top of the aluminium with aluminium foil. We cover aluminium foil here. So aluminium foil is a good heat conductor with the smaller value of C, right? Yes. So Jimmy gives C. So we see whether the answer is correct or not. Okay, so here I also have an idea with Jimmy. So because just like I mentioned, we cover the aluminium block with aluminium foil. So the heat will be released more to surrounding because the aluminium foil with small value of C will be a good heat conductor. So there will be more heat loss. So this one is cannot increase the accuracy of C. So should be C. Okay, answer from Jimmy is correct. Good. Okay, so we look at D. So pour some lubricants oil into the hole where the thermometer is inserted. This is also one of the precaution steps just I mentioned, where we can increase the thermal contact between aluminium block with thermometer. Yes. So answer is very clear, is C. Okay, so good, Jimmy, for your try. Okay, so now we go for question number 5 before we take 5. Okay, so diagram 12 show 1 kg of liquid being heated using an electric heater for 10 minutes. Okay, the temperature of the liquid is increased faster by, so how we can increase the temperature of the liquid? So that means that we have to look at the relationship, right? Q equal to MC theta, right? So the theta will be equal to Q over MC. So to increase the value of temperature, you can increase heat provided, or you can decrease the mass of the liquid. Another one, you change the material of the liquid where have smaller C, right? We can using the formula to discuss what you can do, right? Okay, so the first option, using liquid with higher specific capacity. Wrong, because here just I mentioned we want to use the smaller. So here we want to use lower. Okay, then reducing the time of heating. If you reducing a time heating, that means that you decrease Q, right? Okay, so here is also wrong. Okay, so answer from Jimmy, C. Okay, we want to see whether answer from Jimmy is correct or not. Okay, so here wrong. We want to increase the heating time. so that we can increase the Q. Reducing the mass of liquid, yes. This is what we discussed just now, right? We want to decrease the mass. So answer should be C, right? Okay, then removing the insulator is also wrong. When the insulator we remove, there will be more heat loss already. So answer is very clear. It will be C. Okay, you can look at the heat hot tips here. So temperature of liquid increase faster if we have lower C. Just now I mentioned to you will be this factor. We want to increase the heating time so that our Q can be increased and we can reduce our mass. So answer very clear, it will be C. Good try, Jimmy. Okay. Okay, so we have complete already our learning standard 1 to 3. We still have another learning standard 4 and 5. Okay, so we will be take a break before we continue. Okay, so please stay tuned if you want. Okay, welcome back everyone. So let us continue our learning standard 4. We still have another 2 learning standard 4 and 5 for everyone. Okay, so for learning standard 4, you should able to communicate to explain the application of specific capacity in our daily life, material engineering, and natural phenomenon. Okay, so this will be discussion how we apply the specific capacity in our daily life. Okay, so in the line here we have Mei Yi. Hello, Mei Yi. Okay, so here the first application we are going to discuss the application of specific capacity in the cooking pot. Okay, so the body, the base, and the handle of the pots are made of different material. Okay, so let us discuss the body first. Okay, so the characteristic of the material we are going to use for body must be lower specific capacity so that heats up quickly. Also, the pots will be heated up quickly and the food will be able to cook faster. Okay, then second, we have to use the lower density material. And lower density material, that means that the weight of the pots will be able to reduce, will be lighter and easy to carry. Okay, then the material also need to be inner for chemical material. Okay, so here we're using inner material so that does not wear with the food in the pots, will be healthy for the food where we cook by using the pots here. So the example of the material for body with these 3 characteristics will be aluminium. Okay, and then here the third, we discuss the characteristic of the material used for the base. Okay, so here the characteristic here will be lower specific capacity again, so that the food will be able to cook faster because the pots will be able to heat up quickly with the low specific heat capacity material. Okay, then the second characteristic for the material base will be we need to use a higher density All this is different with the body. Okay, because the base with higher density, so we can make the base become heavier, and it will be more stable, prevent the pots from toppling easily. Okay, the suitable material suggested here will be copper. Okay, then the handle, number 4. So let us discuss the characteristic of the material when able to use as handle. So here, larger specific capacity, because the handle will be the parts where we need to hold when we cook, right? Okay, so with larger specific capacity, so that means that the temperature of the handle will be not increased too fast. So it will be not too hot, even it absorb the heat. Then must be poor conductor of heat, so that the heat loss will be minimal. And then the density must be low, so that the overall weight of the pots can be reduced. Okay, so that means that only the base we need to have higher density material. Other than that, we don't need. Okay, so the example of the material here, we have wood. Okay, so now we going to second application. So here is the working principle in the cooling system of car engine. Okay, so this is a car engine. Okay, sorry everyone. Okay, so here this is a car engine. Okay, so we have a radiator. You can see radiator is actually just in front of our car. Is this part. So inside here there is a fan, cooling fan, and then they have water pump, thermostat, and engine. This is actually the engine parts. Okay, so the water as a cooling agent. Okay, so the water is used as a cooling agent in the cooling system of car. So why we select the water? Okay, water is used to cool internal combustion engine, such as car engine. So you can look at this figure. This is an engine, will produce a lot of heat. Okay, and need to be cooled down by using the water as a cooling agent in this system. Okay, so why? Because the water has a large specific capacity. So that means that when it absorbs a lot of heat from the engine, so the temperature of water will still not increase higher. Okay, it can absorb a lot of heat without large rise of the temperature. This is what I discussed just now. Okay, so water is also easily available and low in cost. So that's why we select the water as a cooling agent in the car engine and others large engine where they produce a lot of heat. Everyone. Okay, so here look at the working principle of the cooling system. We're using the water here. Okay, so the figure shows how heat is removed from the engine and released to the surrounding using water as a cooling agent. Okay, this is the engine. Okay, we look at the step 1. Okay, so 1 here is has a water pump. Okay, so a water pump circulates the water through the engine. So that means the water will be pumped through the cooling system at this point. Okay, and then water enter the engine. Okay, so after the water pump in, the water will be go to engine. The engine is actually here. Okay, it's here. Okay, again you see the radiator is actually in front. Just like I showed already, will be at this position. Okay, and then the fan, radiator fan is actually here. Okay, so the engine is actually inside. But here we just want to discuss the cooling system we want. Okay, so the heat released from the combustion of the petrol air mixture is absorbed by water flowing through space in the engine wall. So this is the engine. So the combustion is occur and a lot of heat is released and will be absorbed by the water. Water is flowed through here, right? Will be absorbed the heat released from the engine. Okay, so this hot water then flow to the radiator. Okay, so the radiator will be here. So radiator will be here, everyone. Here, this is a radiator. Okay, so radiator function is radiate the heat to surrounding. Okay, so that means remove the heat from the engine. Oh? Okay, so number 5 will be here. You see number 5. So number 5, you can see the arrow. So the arrow here showing that the air, the cool air from surrounding will be go inside because of the radiator fan. Okay, so at radiator, a radiator fan draw in air from the surrounding. So the cooler air absorb heat from the cold water and heat loss from the cooling fin to surrounding. So you can see here we have dash, right? So the dash here is actually the cooling fin. Okay, so the heat will be released to the surrounding. Okay, so this is how the cooling system reduce the temperature produced by the engine during the combustion. Okay, so the sea is a sea breeze. So that means during the daytime, if you stand on land, okay, so the air will be come from the sea towards yourself. Okay, why? So this may explain through the specific capacity. Okay, so during the daytime, the surface of land and the sea will be absorbing the heat from the sunlight. Okay, so since the land have the lower specific capacity, so the land will become hotter. So the temperature will increase faster. Okay, it's hotter compared to the sea. Okay, so that means that hot water, sorry everyone. So the hot air will be air will be expand because the temperature is higher. Okay, will be rise, and here may cause the pressure is lower at this area. Okay. Okay, so as a result, the temperature of the land become higher than the sea. This is what I explained already just now. Okay, so the hot air above the land expand and rises, creating a lower pressure region at here. Okay, so the colder air above the sea will be at here, will be moved forward, okay, move towards the land and replace the rising water air. So this is how we can feel the wind come from the sea. And this phenomenon we know as the sea breeze. Okay, same application will be at the land breeze. So during the night, the wind will be blown from the land to the sea. Again, this is because of the specific capacity of the land is smaller and specific capacity of sea is higher. So that means now the sea become hotter, or because specific capacity of sea is higher, causes it condense more heat, right? Will be take more time to release the heat compared to the land. So land with smaller specific capacity, heat will be lost very fast. So the temperature will be lower at the land, then temperature will be higher at the sea. Okay, so this causes the air expand and rise. Okay, so here will be the sentence. During the night, the land has a lower specific heat capacity than the sea. It cool down faster. Okay, so as a result, temperature of the land become lower than the sea. So temperature at the land is lower. So the hot air above the sea expand and rise. This is what I mentioned already. Okay, so creating the low pressure region. Okay, so the colder air above the land will be moved towards the sea to replace the rising warm air. This is a discussion regarding the land breeze. Okay, so here we complete our learning standard 4, so that we go for our checkpoint first before we go for our last learning standard. Okay, so diagram 15 shows a pot. Now students, you may show your answer in the chat room. Again, okay, so why pot's handle? Pot's handle made of high specific capacity. Just I mentioned to you already. So high specific capacity, that means that temperature rise will be decreased, right? It will be not easily getting hot when we hold the handle when we cook. Okay, so a substance with high specific capacity absorb larger amount of heat, but temperature increase will be smaller. Okay, so here, to increase the mass of the pods is wrong. To reduce the increase of temperature, seems like this should be correct, right? So to increase the melting point is also not related. To reduce the expansion is also not related. So I'm think that the answer is very clear, is B. Okay. Okay, then we go for question 7. So at night, land cool faster than sea. So cool faster because the specific capacity is smaller for land. Okay, so which statement explains the situation? Okay, again, the tips here is I mentioned to you, land has lower specific capacity, so it may cool down faster. So answer from Jimmy, B. Okay. Okay, so let us go through. Is the answer from Jimmy is correct? Okay, so here, first, solid release heat faster than liquid. Okay, so this is not related. Okay, so sea absorb heat more than land during the night. Okay, so during the night, actually the heat will be released. Okay, we discussed about the heat release. Okay, so the breeze blow from the sea to the land. So the sea breeze will be occur during the daytime. Again, B and C we are confirmed wrong. Okay, specific capacity of sea is greater than the land. Okay, answer. I think B is just now question, right? Jimmy, just now question number 6 is B is correct. Okay, so now your answer is D. Okay, yes, answer is D. Okay. Okay, good try, Jimmy. Yes. I noticed already is number 6. Good. So that means both answer you get correct. Okay, so now we go for our last learning standard. Okay, is regarding the problem solving involving specific capacity using formula QU to MC data. Okay, so this is a problem solving question. Okay, so here we have one. We had another 3 questions, 8, 9, and 10. Okay, so the question number 8 is the objective. 9 and 10 is actually the subjective question. Okay, so the question for number 8 will be like this. 17,600 joule of heat is used to increase the temperature. Okay, so you can just using symbol for the value given. Okay, then the mass here is M, but we have to change to kg. Then the temperature changes will be 30 to 55. So this is the delta T. Okay, so what is the specific capacity? C. Okay, so you have to substitute the value. Okay, so we're using this formula, then we rearrange. Okay, so here, just like I mentioned, we're using Q with this value, 17,600. Okay, then we change the M to 0.8. Okay, then we change we substitute the temperature change, the 55 minus 35. Okay, then we arrange, okay, we get 880 joule per kg per degree Celsius. So answer is D actually. Okay, then we go for question number 9. Okay, so question number 9 is a problem solving question where related to energy transfer. A1. Okay, so actually we have learned a lot of the energy transfer. So here is one of the question. Might be C. So that means that there are many types of other questions actually. But we have limited time actually to explain different type of the heat transfer here. So now we focus on one type first. Okay, so at a certain section of the Victoria Fall in Africa, water drops vertically from the height of 480. Okay, so that means the object is fall to the ground. Okay, so explain why the water at the base of the waterfall has temperature higher. So that means here the water from high position is actually lower temperature. But when reach the ground, the temperature increases. Okay, so why? The question asks. Okay, because here at the high position, we have the gravitational potential energy, right? It's actually absorbed by the water. Okay, you can see as the water fall down the waterfall, it lost the potential energy. So the parts of the potential energy converted into the heat energy. You can see here. So which increase the temperature of the water at the base of the waterfall. So that means here we have the energy changes, causes the temperature increases. Okay, so here the question asks about estimate the maximum possible difference in the temperature. So the question asks about the temperature changes. Okay, between the water at the base and at the top of the waterfall. So that means that we have the conversion of gravitational potential energy. So the potential energy to heat energy. And heat energy. So the heat energy will be absorbed by water by using MC data. Okay, then the gravitational energy here will be mgh now. So you have to cancel your m. So gh become c delta theta. So delta theta will be c over gh. So the c is a specific capacity of water. On just now, we already explained it's about 4,200. G we're using 9.81. And then the H is height given at 480. Or 480, just now we have discussed already at the question. So you just substitute all the value and then you can get the answer actually. Okay, so you can see. Assume all potential energy lost by the falling water is converted to the heat energy. Okay, so we're using mgh equal to mc theta. Then we cancel the m. So we get 1.12 degrees Celsius. So the change is actually very small. Again, G we're using 9.81. M we're using 480. C we're using 4,200. So we get a delta H, which is equivalent to 1.12. A1. Okay, so now we go for our last question. So the last question is actually the paper 2 section A question. This is a decision making question. So we'll be at question number 7. Okay, so what is the meanings of specific capacity? So again, we have to discuss by using the formula, right? Q equal to MC theta. So C equal to Q over M theta. So that means it is the heat required to increase the substance with 1 kg with 1 degree Celsius. All this is what actually you can using the formula to give the definition. Okay, so answer the quantity of heat required by a substance or 1 kg mass to increase its temperature by 1 degree Celsius. You can using formula to discuss. Okay, then the second question. Okay, so students, you may give what is the most suitable model used or A or B or A1 in the chat room. We are going to select A or B model for suitability for cooking. Okay, so here, based on the information in diagram 8, state the suitability characteristic of the frying pan used for cooking. Okay, so the type of surface, you can look at the diagram and table. Okay, diagram 8. So the model A with the bright surface and then B with the dark surface. Okay, so which surface you have to choose? Okay, so actually you have to choose dark surface. Okay, because dark surface can absorb more heat. This theory actually you learn at the PT3 level. So the heat dark surface is a good heat absorber or heat radiator. Okay, so here the first B1 surface we choose dark. Reason because dark surface absorb heat better. Then for the second specific capacity, here we have to choose higher or lower. So for cooking, we need the food cook faster, so that we want the temperature increase more. That means that we have to choose smaller or lower specific capacity. Okay, so that the temperature will be rise faster. Huh? Okay, low specific capacity. So reason heat up faster or food can cook faster, right? Okay, so the next question. So based on the answer in 3B, okay, so determine which model of frying pan in diagram A will absorb heat efficiently. Just now, we explained already, we will choose the dark surface. Or we will choose the dark surface. Yes. So answer from Jimmy, B is correct. We're using the model B. Okay, good. Okay, so because the dark surface and low specific capacity, this will be the answer. Give your reason. Reason there will be dark surface and low specific capacity. Okay, so the last question here is the calculation question. Or D. A kettle contains 0.5 kg water. The average heat absorbed by the water will be, sorry, everyone. Okay, so will be 16 joule per second in 25 minutes. Okay, so calculate amount of heat absorbed by the water. You can see 1 second, 16 joule. So 25 minutes, there will be how many heat will be absorbed. So that means that we have to change the minute to second, multiply with 16, right? So that we know the amount of heat absorbed by the water. Okay, so this will be the answer. You see, just now I mentioned to you, 16 joule per second. So the 25 minutes use have to change to second. So we get 24,000 joule. Okay, so D2, the rise in temperature of water. Okay, so here, that means that this is Q, right? So we are going to, using the formula, Q equal to MC theta, right? So Q we have already. Mass, question given us 0.5, you can see here. Here will be 0.5. And then specific capacity of water given as 4,200. Then we can know what is the rise of the temperature here. So we just substitute all the value given. 24,000 is get from D1. 0.5 is given by the question. 4,200 also given by question. So we just rearrange so that we can get the answer. So again, advise you that the answer must be minimum 2 decimal places with correct unit. Okay, so this will be all related information for Learning Standard 5, and so that we complete already our subtopic of 4.2. You want? Okay, so now I would like to share to you the link e-schedule peringkat kebangsaan to the chat room. Okay, you may fill out the link with any email you are available within 30 minutes. Okay, so again, please like my lesson today so that there will be more people will be receive the notification for this lesson. Okay, so like, share the link to your friends so that more of your friends are able to get the benefit from my teaching video. Okay, and again, I want to remind you that the next physics classes will be as usual. For the non-DLP Form 5 group will be held on every Friday, 8:30 p.m. And then the Form 4 DLP class will be held on every Sunday, 8:15 p.m. Okay, so the next lesson will be presented by Cikgu Hasnitah with the subtopic of 4.3. Okay, so thank you everyone for following me and support me until now. Okay, again, thank you Jimmy and others who are still staying in the line. Okay, so please fill out the email, fill out the link schedule within 30 minutes. So see you again. Bye bye everyone.